All right, we want to do some more integration by parts. In the first video, we did polynomial times a sine. We did a polynomial times a exponential. On this one, I want to do an exponential times a trig function, exponential times sine. Um, Again, these are a couple unrelated things where a u substitution isn't going to work for us. When I'm looking at integrals, generally the first thing I'm looking for is a u substitution. Failing that, then I look at what else I've got. This is a product of a couple of unrelated things, um, so I'm inclined to do integration by parts. So let's see, I've got u, du, v, and dv. Okay. There's a couple of things that are going to happen on this, and I'm going to do this problem twice. Once in a way that gets me to an answer, and then I'll come back and do it again to illustrate something you might run into, um, and it doesn't end up giving you an answer. But I just want to show you that it looks like you're doing the right thing, and you are doing the right thing. It's just that it doesn't get you where you want to go. So I'm looking at this thing thinking, I've got to make something the u and something the dv. All right. The dv definitely has to be something I can integrate, because it doesn't make any sense to put something here if I can't do the integral of it. So, but in this, I've got an exponential, I've got a trig function. It doesn't really matter. Each one is pretty easy to integrate, pretty easy to differentiate. I think just for myself, I would be inclined to put the sine of 3x right here, because the derivative of the sine x is the cosine. Chain rule gets a 3 out in front, right? Without a minus sign. And if I can avoid minus signs, I usually feel like I'm better off. So having put the sine x there, the e to the 2x dx has got to be over on this side. Okay, so with the dv. I think I've got everything accounted for. The sine 3x is in the u, and the e to the 2x dx is here in the dv. When I take an antiderivative here, this is going to be 1/2 e to the 2x. Okay, so my integration by parts, remember, let's put it over here. Let's see, the integral of u dv is u times v minus the integral of v du. So I started off with u dv, started off with u and dv. So u times v is 1/2 e to the 2x times sine of 3x minus the integral of v du. So v is here, 1/2 e to the 2x times 3 cosine 3x dx. I'm going to simplify this a little bit. By getting the 3.5 together. So that was equal to 1/2 e to the 2x sine 3x minus 3/2 times the integral of e to the 2x cosine 3x dx. So now I look at this and I say, well, is this integral any better than the one I started with? Huh. I'm not sure there's any better, but it certainly is different, right? I started with a sine, and now I've got a cosine. So, well, okay, let's just forge ahead here and see what we might be able to do. If I were presented with this integral, I would do integration by parts. So let's try it here. I've got u, a du, I've got v and a dv. I'm going to, or I used the trig function here as u. I'm going to do the same thing again, use the trig function. So I'm going to put the cosine of 3x there, and the e to the 2x dx down here as the dv. So taking the derivative of the cosine of 3x, I've got minus 3 sine 3x times dx. And taking the integral of e to the 2x, I've got 1/2 e to the 2x. That is v. Okay. So, where am I? This is equal to 1/2 e to the 2x. I've already got that here. Sine 3x minus 3/2 times, and make sure you put this in parentheses because all of this integral is a couple of pieces here. So I need u times v. So I've got 1/2 e to the 2x cosine 3x minus the integral of v du. So that is, oh, there's another minus. The minus, well, let's put it in here. So this is minus, I see a 3 over 2. I see an e to the 2x. and I'm running out of room here. Let's see if I can move this over, get a little more space. Come on now. Why won't that move? There we go. Give myself a little more space. Times the sine of 3x here. Dx. And close parentheses. Awesome. So, I think I'm back to what I started with, but let's distribute things through here. So this is, actually I'm going to state this, the original integral I started with was the integral of e to the 2x times the sine of 3x dx, and that's equal to 1/2 e to the 2x sine of 3x minus, what's this, 3/4 e to the 2x cosine 3x minus, how many minus signs do I got here? I got a minus, 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 so that looks like a minus sign there, minus 9/4 times the integral of e to the 2x sine 3x dx. So indeed, I have gotten back to the integral I started with, which maybe it's not all that bad. I mean, you could think of it as bad, as like, wow, what did I do? But I got some information here. I'm not just saying that this integral is equal to itself. I'm saying that this integral is equal to all this stuff minus this times itself. Which actually, if I added the 9/4 times that integral over to the other side, I'd have the integral of this stuff plus 9/4 times the integral of this stuff equals all this other stuff. 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x. But 1 times this integral plus 9/4 times this integral, think of that as 4/4, right? So this would be 13/4 times, for some reason computer's slow, there we go, times the integral of e to the 2x sine 3x dx equals all this stuff, so 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x. And now I can divide by this thing or multiply by the reciprocal, so I'm going to multiply by 14/3 on both sides. And I've got the integral of e to the 2x sine 3x dx equals 4/13 times all that stuff. 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x. And one thing that gets lost when you do this, when this integral gets pulled back over to the other side, is that there's a plus c that should have come out of that, and we didn't bring it along, so I need a plus c on the end. So anyway, there's that integral. We integrated by parts twice and ended back up with the same integral we started with. But the thing is, I got an equation and I've got some information here. So get this one back together with that one and then divide by whatever coefficient you end up with right out in front there. Anyway, there you go. I am going to actually in a new video do this another way. Actually fail to do this in another way, but it's something you might run into from time to time, so I want to show you an example of it.